Today I'm talking to with Yves Reynhout, who is an independent developer, but and must say modeler extraordinaire. I need to say that. I'm gonna let you speak a bit about you before we go to the topic at hand.
Yeah, hi Yves. I'm also Yves, so that makes it really confusing, I would say. No, I'm a software developer and modeler, basically, bit at the both times, basically. And I mainly work with clients doing things ranging from really hands-on, implementing the design we came up with, as well as exploring, basically, there's this problem we have. How do we go about it? Usually that involves a lot of finding the boundaries of things. Um, and so, yeah, I try to both have a good grasp of the analytical side, I would say, of things, crossing over into the design of, so how are we going to go about this? And then actually also helping out with the implementation of the software.
Yeah. And yeah, and speaking of implementation and design and modeling, when we talk about event sourcing, we have those rule of thumbs, you know, those rule we try to get into people's head, like, oh, streams should be short-lived, streams should be short, not too much even. Don't have like 1 million events in a stream for the rest of your application or system life, and a few others, but we do have exceptions.
Yeah, we do. And I think for a lot of these things, it's about knowing when that might be suitable or suitable enough, basically. So I think it was about 3 years ago I engaged into this project. Um, and I mean, over the course of time, I've done this basically as a part-time thing. And yeah, there were already a lot of decisions in place, and I think it's not uncommon. What might be less uncommon is that they've picked basically event sourcing as a way to go about it. And they knew that I had quite some experience with that as well. So that was what made it a little bit attractive to me, I would say. But then the problem I was presented with, I was kind of questioning myself even, well, should I even be applying event sourcing in this case? But yeah, for some reason that ship had already sailed basically, and we settled on this. So it was up to me basically to find out and to navigate how to go about that. And so the problem space is one of connecting roads together, basically. So it's a very geographic thing. And we think about that, for example, is that a lot of these roads, I mean, have you ever driven on a road and I mean, obviously there's an end to a road, but there's no road in the middle of nowhere where there's no beginning and no connectedness, right? So a lot of the things we had to do was making sure that everything stayed connected. I mean, you couldn't go basically somewhere and just draw a new road which wasn't connected to the rest of the graph of roads, if you will. And that basically was a clue to me that it would make a lot of sense to have these small, short-lived streams, because there was some kind of rules basically needed to be consistent all the time. I'm not saying you couldn't break it, but it made our lives so much easier basically by keeping everything in one stream. So that kind of caused yeah, things which we were normally, yeah, when you normally live with smaller streams, then yeah, there's stuff that's you're taking for granted, like oh, my load times are really small. applying the next command. It's really, really easy. Getting those events out is really easy. And so you get a lot faster basically into the area of, oh, we're probably going to need snapshotting at some point here to basically keep up the speed at which we'd like to go. Now, another side note I need to make is that this was not a high transaction volume system. So we're talking in orders of initially, I would say, of maybe 5-6 updates per day to the stream. So that's totally negligible. Scaling up to maybe around 250 a day, basically. So that made it so that you don't need a lot of these high-speed things, these low latency and no concurrent, and well, dealing with concurrency, basically, those were all kind of out of the picture because a lot of that low volume was perfectly, you were perfectly able to deal with that using a single stream at that point, and also a single writer on top of the stream at that point.
Yep.
And
yeah, so low concurrency issue, 5-6 updates, or let's say 100 per day.
yeah.
So are those kind of the things you always look at when you're trying to model streams and so on, like rates?
Yeah, rate of change is basically a big indicator of how you would model this, and whether or not, for example, in this particular case, putting everything in one big stream was an acceptable trade-off to make, because it wasn't, you weren't going to jeopardize basically even when we looked, because I did look a bit ahead into the future and what they wanted to do further on with the system, and with the knowledge I had at the time, there wasn't a lot of indication that this was going to be some high volume or becoming a high volume system. This was always going to be fairly slow changing. We're talking about maintaining and creating new roads, basically. How often does that happen? Okay, it happens on a daily basis in a lot of places across the country, but it doesn't happen like, it's not in the same order as shopping baskets and warehouse traffic, for example. It's all much more low volume, basically, compared to those type of things.
Yeah, and so I guess that everything that had to do with building up read models or doing other kind of processing, since there were few updates a day, you have probably had some kind of enough time to process the data.
We did everything. So the feedback loop to the end user and or automated processes was always asynchronous. So nobody ever had to wait. We always said, thank you for your updates. We're going to process them, because by having a single stream, you're inherently also creating a queue, if you will, of all these updates. So everybody ended up basically in a queue and waiting for their update to be processed, which was acceptable again in this case because of the low amount of updates that were coming in. And racing didn't make a lot of sense. It would have introduced accidental complexity. Why? Because because there were all these rules around these interconnectedness, and I mean, there were a lot more than just the interconnectedness, but that was one of the main drivers to make sure that everything was still properly connected to one another. And there was even room to kind of do, how would I call this? In the future, I would think that we would be able to support concurrent updates, because if, for example, if you're doing an update basically on one side of the country and somebody else doing an update on the other side of the country, the fact that these two things are going to be connected is probably close to zero. So based on the command data that's coming in, basically, you would be able to draw bounding boxes of seeing, well, which area is being affected, and even allow basically for concurrent updates to happen if that would help with the throughput of it all. But we didn't, I mean, there were no indications we needed to go that far initially. So as I said, yeah, the everything was from a feedback loop point of view was asynchronous. So the users got their feedback basically via an activity view, in which they saw, well, okay, this is the action I've done. Here's the feedback we've gotten, because the complexity was more around all the minute rules and whether or not there was a lot of chance of human error, basically. So that's why a lot of these things got checked. And they would also need this kind of feedback at a very granular level, like something's wrong with this geometry that you've drawn over here, or something's wrong with these attributes of this feature that you've drawn over here. So those type of things is the kind of feedback that we're looking for, and we try to make that as foolproof as possible, such that if we accepted something that we were sure that it was going to fit basically into the rest of what we already had. Which is also interesting because there's a whole offline aspect to this. So what they typically do in their workflow would be they would download an archive, so a zip file or something like that, and they would do a lot of manipulation on the contents of that, preparing it, and then they would use their regular tools basically that they were used to using to do then manipulations on that data, and then they would basically compare what they started from and what they ended up with, and those would be the kind of, it's like a diff basically that you get of the changes that they've performed, and those would get uploaded back basically to the system, where the system then needed to figure out, so what are the instructions that are being sent to us? Because you have to remember, there's some arcane formats that we had to deal with, like really old file formats from the 90s, dealing with binary data. Not that is so exceptional, but I mean, that was a given constraint, I would say. And so there wasn't a lot of wiggle room to make these things very smart, even though there are, at least in the geospace, there are much, I mean, the geospace itself was much more advanced, but they weren't ready, their consumers weren't ready to pick up new standards, basically, let's put it that way. So there wasn't a lot of wiggle room with regard to how they would communicate changes to us. But we kind of succeeded in insulating the rest of the model that had to deal with these updates from these file formats. So we would have like an anti-corruption layer, an explicit translation, basically, from what's in the file, what kind of changes are you telling me, and we translate that to very explicit things like, I basically like you to draw a new road over here, or change some of these attributes, or remove that one. So we kind of made a fairly cruddy set of commands, basically, that they would send to us. And that put another, so when you're dealing with these binary formats, they kind of require you to specify in their headers, basically, how many records are you shipping to me, and how long is this file going to be, those type of things. So you typically have to write the header before you're writing the records themselves. And that put an interesting twist on things, because you couldn't just go and say, well, I'm going to send off X number of commands, because from their mind, if they're giving me a set of changes, there was an expectation of atomicity, like either all these changes go in or none of them go in. And if none of them go in, well, at least tell me what's wrong with them, right? So that was kind of easy. But also, if it was accepted, there was this kind of assumption, I would say, from the rest of the system that this was a package that you got as a whole, basically. So from a design point of view, instead of having all these fine-grained granular commands, what we did was we created one big command with inside of it a lot of smaller commands, if you will, which would then be applied. So I think other people call this batch commands, right? So where you're aggregating a lot of changes and then applying them all in one go. And because we got the single stream and the single entity sitting on top of it, that made it a natural choice basically to do that. But also on the other end, right? So because you could model a batch command and then have all these fine-grained events coming out, but that was not a good idea because the consumers would at that point have to do their own kind of transaction management. They would have to listen basically for what's the first thing in this set of changes and what's the last thing, to then make it observable to anybody that was consuming these projections. Now, for some projection, that would be fine. That's totally okay. But in this case, because we had to write basically at a certain point, there's this many bytes in this file and there's this many records, you had to have a consistent view on all of that. So what we wanted, or what we did, was basically did the same thing we did for the command. We created one big event with all the changes listed in it, and then had that basically being consumed by the projections, which then would commit all of the changes they needed to do as one big transaction. So we're using a relational database for that, which made it easy to have cross-entity, cross-row transactions, obviously, and then commit that as a whole. But that was not the end of the story, because if you think about it, when you're writing queries to a database, then you need a transaction around that as well. Because what happens when a projection is already consuming the next batch of changes, basically, while you're reading, because reading would take a while, composing these files would take a while. So what we did there was using read committed transactions there, so that we know for reading, that we know that if we were looking at this database at a certain point in time, any future changes that would come, we would not observe, basically. So if a row was there, it was still there, even if a change after it can cause that row to be removed. So that was an interesting way of approaching that particular problem. And it steered some of the design of the commands and the events in this particular case.
So if I understand correctly, so on the consuming, so you got the changes, they're coming in kind of batch applied as one big transaction, let's say, on the store side, on the event, the stream store side, and then that outputs one event with a lot of changes in it.
Mm-hmm.
So
Yeah.
kind of composed thing.
Yeah, exactly.
And then the consumer, actually, the consumers of those data actually need to have the same kind of view
Consistent.
of as the data. So there's a consistency in, okay, this set of changes need to be consistent and viewed as a set of changes. And if I'm looking at set of change from as a particular set of change now, I don't want to be troubled by things that are beginning to come into that part of the system.
Yeah. So
Cool.
So you had this big queue where changes were only being applied basically one after the other, but we didn't pause until the projection system had caught up. We just keep on processing basically, and that will cause new events to be written. And the projection system didn't wait until you were ready with reading all. I mean, those would have been trade-offs we could have made, and alternative ways of implementing this that we could have made. No, but that was an interesting, I would say, wrinkle on the whole problem. If you simplify, if you look at it from the outside, I mean, it's just a big command and it's a big event basically being produced there and you'd like to have a consistent view on your data. And we lean on a database to basically to give us that consistent view. That there's other things that we also entertained, which was to, instead of having this model that you could query basically, because you have to think of it, the reason why we put it in the database, we were kind of, I wouldn't say abusing the database. We still needed some of its querying capabilities. So, for example, some people would like a subset of the geographical data. So we'd lean on the geographical types in the database to be able to ask geographical questions, such as, give me an extract basically of this this area, for example. And this area could be whatever. They could bring basically their own area in that case of how they'd like to see the data. But we projected very close to the file format. So this was binary, right? So so we created basically the way the record looked in a binary format. We projected basically a bunch of binaries basically into the database, such as that it became almost like a key value store, if you will, where this key and basically here's the record that goes with that. It was a little bit more complicated than that, but not too far off from that basic idea. I see a lot of people basically going, when they need to deal with something like this, and they're going, well, let's build yet another third normal form relational model on the projection side. And then they're doing their queries, doing all the mapping basically in the querying layer. We basically said, well, let's move that mapping basically closer to the projection. Because this was asynchronous already, people could wait a few more seconds basically for that. I mean, it wouldn't make all that much difference in the grander scheme of things, I would say, of throughput. So we moved that mapping logic inside the projection itself, and then we got a bunch of bytes which we were almost like concatenating one after another, and that would be your file at the end of that process.
So not projecting onto what we're mostly used to, a document data, or directly into a document database or a graph or but actually generating binary data that can be directly consumed by some system.
Yeah, exactly. So composing because the records were all the same, regardless of the geographic area that you wanted to get. It was just that. So if you got a big geographic area where there were a lot of roads, let's put it that way, because that you can also have areas where there's a lot of forest, there's not a lot of roads there, right? But if there's then your data set would just become bigger, but the binary data would just remain the same. It's almost like the only thing that changed was the header of the entire thing.
If you're out, what kind of tools were consuming that?
Those were mostly GIS tools. So they would, people are kind of used to work with, they're called shape files, right? So people are kind of used to working with that. And they were consuming that data basically in their own environment, using their own. I mean, we as developers have code editors. Well, they have their own GIS tooling basically that consumes these files, and they're used to working with maps and with layers basically on top of one another, and it being able to draw all these things. So it had a very visual aspect to it as well, but that was largely sitting outside of the automation that I performed.
Yeah. So if I understand correctly, the projection or the read model, let's say, that you just described, the end user chooses, okay, I want details of that area, and you projected that directly into whatever binary format they can consume.
Yeah, exactly.
Cool. So, that's really cool. Really.
Yeah, I mean, for a lot of these things, it's looking at who is interested in this data and how do you want to see that. And you could stop there and think, well, I can map everything from a relational layer. True, you can do that. And if there's a lot of churn in that, then maybe it's a better idea to do that. If you have to support a lot of formats, sure, then it makes sense to make a more canonical, if I dare to say that word, model of that basically on the projection side, and use a query layer to do the mapping. But here we were in a position where, yeah, the format was known, so it's fairly easy to come up with that.
I've done that for kind of the similar idea to give the data in a form that is more easily consumable for user for my BI friends, where instead of just, okay, here's a list of the data. No, what do you really need? Oh, you need quarterly data. Oh, you need every day. Oh, you need this and you need that. Oh, please tell me more, because I'm interested into what you need, because that's necessary for, okay, I need that as input as well somewhere to be able, and to transform it directly into data that they can more easily consume in their ETL processes. So instead of having like one list of saying this day and some timestamp, it's like, okay, this is the quarterly stuff, this is the daily stuff, this is the whatever that they need as data. And it was kind of interesting, because then you talk to those people and you begin to understand, okay, all those reports are doing, what are they using it for, and getting to know the business better and the needs. But kind of the same idea, projecting into something that is easily, more readily consumable, that there's no additional transformation needed by or less, at least in my case.
Yeah, exactly. Those weren't the only projections that we did. We had another projection that was more running on a schedule, basically, where somebody needed a daily update of kind of obviously the same event streams, but presented again a little bit differently. Didn't have these consistency needs, if you will, but got them anyway out of the box because of how things were set up, basically. Yeah.
Cool.
Well, another, I mean, I said in the beginning, long streams. Where did the long come from, right? So with any system where if we use the word legacy, not in a negative way, but in the fact that there's something there already, I couldn't fully expect people to start redrawing that whole network. Basically, that was already there, and it was there in a relational form, which kind of mimicked, I would say, the binary format in a way. So what we did there was to perform an ETL process. And what was kind of interesting there was that there were two environments. So their new setup basically was going to be in a cloud environment, and their old setup was in more in an on-premise data center, if you will. And we didn't want to be dealing with, for an ETL process, we didn't want to be dealing with firewalls and getting all this connectiveness going. So we split the ETL process up into the ET and the L, basically. So you do an extract and transform. And what we did there was just simple SQL queries that would read in the data, transform it into events. And we looked quite a bit of time for what would be the suitable events for this. We didn't really find a good scene, to be honest. The best we came up with was around the entities that were in the domain. Basically, we had these imported events. So imported X, or imported a road, for example, things like that were present in this space, which we then mapped on. Well, the data we then mapped on the events. And we created a big file out of that. And the file was a format of, in this stream, I needed to write this event, basically. And you had a big array of that, basically. So we built a little story up. And one of the interesting things we did there as well was to introduce marker events. Basically, the one event said, hey, we began with importing from the old system. And the other event said, hey, we completed importing from the old system. And that was very beneficial because you had a lot of other stuff that would already be running, and you could mess up the system if you were doing this while while the import was still running. So there was this kind of implicit contract between these things that they would only start doing things as of the moment they saw completed the import. And so that gave us a nice property to, for example, give into the in the UI, from an API, we would return 503, and then the UI would know, hey, we're still busy doing stuff. Please hold on, keep waiting until we're done with this, because that was quite some data. And another added benefit from doing the ET separate is that, yeah, I mean, in the beginning of my career, I thought, well, I'll write perfect software. that bubble got bursted really quickly. So what we did was we could basically do this ET process over and over again. So as the data was basically moving on in the current production system, we could basically take a backup of that database, run the ET basically, and get a fresh set of data to work with. And making that process repeatable, and also be able to do it offline, also catered for, oh, I need to develop feature X or Y. I'm going to need some data to be able to do that with. So that supported the development lifecycle as well, where it was fairly easy to reset your database because you changed something to the import. We forgot to import some data, for example. Then at that point you could change that process. So as we iterated on that, that was a valuable way in doing that. But that produced at the end of it produced a big archive, because fitting the file on disk as is. I mean, we serialized to JSON, so JSON is already fairly verbose. And I think we ended up with 2 gigs of data at that point. But archiving it reduced that again to a much more saner number, somewhere around 200 megabytes or something like that. And then the load process would be separate. So what we do basically is to be able to do the load process, we just upload the data into the cloud environment, into some bucket, because it was just a file. And that process would just go look at the bucket and see, well, is the file already there? And have I done an import before? No. Okay, I'm going to kick off and do that, basically. And so you got this nice separation going on. Because as much as effort that you put into an import, unless it's continuous, this is a one-off, right? This is something that you're doing once until you get it right. So there's that space. I would say you iterate over it until you get it right. And you're saying, well, now we're fairly sure that what we have here, we're happy to deal with any of the consequences of not getting it right. That's basically all software that you can kill, basically. So the rest of the ET process and the loading process, basically over time, it's all software that's basically you're able to remove at that point. And these weren't complicated applications, right? It was just a simple command line driven utility that would perform this either ETL function, basically, depending on what you passed in. So but that was interesting nonetheless. So the fact that we got a lot of the legacy data meant that we already had a lot of data to begin with. So we had a very long stream. I think we were, just doing the import, we were at about 1.8 million events, basically, already in a single stream. And we hadn't done anything with the system at that point. So then the fun needed to begin. And that tied into the snapshotting. I didn't introduce snapshotting to begin with. I just said, okay, let's measure how. But then I was sitting there and waiting for everything to get processed, basically, and building up the state. Because the reason we put a lot of this data into or the events into the same stream is because we needed a fairly good data model to sit behind it to answer the next question. So that typically the state that you project into your entity was going to be fairly big, because there was a lot of roads in there, basically, which had a lot of properties that were interesting that we needed to remember to be able to answer the next question that came along with the next change that came along. And to do that, we started measuring, and it wasn't really acceptable to do that. Even if it was asynchronous, still it wasn't living up. So what we did at that point, we said, well, you know what, we'll let the import run basically, and then again, piggybacking of this completed event, basically, we'd say, well, oh, that's our first indication that we need a snapshot. So we just build up a snapshot at that point of the system. And then going forward, there were kind of two main events going into the system. One said, yeah, your changes got accepted or your changes got rejected, basically. And they both had their payloads. If they got accepted, we'd obviously translate all of the minute commands basically into minute events in there so that our system would know what we've accepted basically. Or if we rejected, then we'd basically report back this change that you tried to perform, it has all these problems. So, and we get a lot of these type of things going in there. And that we projected, we appended to the stream as well. So these were bigger, but if you rejected something, state didn't change. So what we did was something was accepted, that was another trigger basically to do another snapshot of the system.
Yeah, that's kind of a system protocol almost.
Yeah.
You know, there's a lot of value in identifying those for triggering next automated work, or triggering humans to
Mm-hmm.
to have them do something, or make a decision somewhere. So that start and stop thing for the people listening is also something that happens a lot when you need to migrate from one store to another, or when you say, okay, I'm beginning to, and those are, little clues for the system to, okay, something is going on, I need to either back off or take some action. So there's a lot of value in those almost protocol-like messages.
Yeah. They're not high in value on the business side, obviously, but it's more about a way to kind of make transparent or observable, basically, what's happening in the system at this point, and allowing other pieces of the system to kind of pick up on that.
I would argue they have value for humans, because then you can tell them something is happening, might take some time or not, or
Yeah.
is
Oh,
almost finished. And I mean, it has value for the user experience, for at least in the domains I've been in.
we did that too. So on the activity overview that they got, they would see, well, I just begun with the import and now I'm done with the import, basically. So they would get some feedback on that part. Obviously, yeah. I mean, as soon as you hit production, that message is useful once, basically. Yeah. But after that, it's not all that useful anymore. But it also kind of segments the data, right? If you have to troubleshoot, did the data originate from something we imported, or did the data originate from after we crossed over? And because you might have entered via different paths into the system, and there might be something off with the data that you've imported, basically, which you're then able to fix well, not manually, but that's another thing, I guess, that was interesting, is that because of the way we structure the commands, you would always be able to kind of, as long as it abided by the rules, you would be able to kind of fix the data without being relegated to how would I say, intervening manually, or writing events directly to fix stuff. You would be able to solve a large swath of problems, I would say, just by issuing another command which would fix and rectify the thing that was wrong before. Yeah.
Nice.
And a new event would come out, and again, everybody would observe, and then the data would be fixed at that point. So even though from the people changing things, they were used to their tooling and these file formats they work with. But on the inside, we got another more expressive model, basically, we didn't go so far as exposing that explicit model in the but I think for in the foreseeable future they probably will allow basically to have these commands which are more fine-grained to rectify things, basically to expose them in and by themselves as well, thereby allowing basically the system to yeah, if you need to do these small fixes, you don't need to go through this whole download, change stuff, upload process, but just issue a command and be done with it, and then
Yeah,
have stuff fixed.
I guess that's so those internal fine-grained commands or
Mm.
events there to correct stuff. Those are kind of power tools.
Yeah. Well,
Yeah,
the thing is, they're not a separate set from the regular commands. They're the same command, which worked in this case, I would say, right?
yeah.
Sometimes I mean, I do implement corrective commands, but I'm always looking for um, is my command not too rigid? Uh, how can I make it so subtle, basically, that I'm also able to change in a when I'm in a faulty condition? For example, you could introduce authorization there and say, well, if this person is actually performing these changes, he's actually doing an override, if you will. You could also model it explicitly, obviously, and say, well, I have another variant of this command, which is basically almost like the same, but then we drop some of the rules on the floor, basically, because we know what they're doing is more
Ah,
kind of a corrective action. So those would be alternatives, ways of going about rectifying things in your system without stooping down to the infrastructure levels of things. You need to make it easy to change those or correct those type of things through your system as much as possible. Um, I mean, there's always stuff that you're not going to be able to do, but it should be like a goal that you strive for to, as you're designing things, also think about what if I need to rectify? Because yeah, in a lot of cases, the rules are so rigid. And if you don't provide some kind of escape hatch, basically to fix stuff, then you're going to be doing it manually, which is a lot more costly, a lot more annoying, basically for
mm,
all those involved. I would say it's not fun as a developer or as an ops person to have to go in and do that type of stuff, and it's not fun as a consumer um, to do that. So in a lot of cases, the more you're able to allow people to self-service, the better, I would say.
yeah, and yeah, maybe off topic, but you mentioned ops and yourself as a developer when you need to fix
Mhm.
things because something is wrong. That's something. I mean, it's kind of off topic, but I find it kind of a pity that in most when we're thinking about the system we build and so on, we don't take those people into account.
Mhm.
We don't take ourselves into account because we are going to need to fix things. We don't take ops into account because they will need to or support. They will need to also be able to see things and do things on behalf of users to fix up. So if there's one thing I want to say today is those are users as well.
Yeah.
Please go and listen to what they need. MBI, MBI.
Yeah. Yeah, they're all different consumers of the same system. I mean, running a system involves a lot of parties, basically. So it's better to acknowledge that they exist and to listen to what they need if they know what they need. Because I mean, sometimes these type of things also have an emergent characteristic to them. Like they're not obvious at the time that you're developing, and if you've done the operational side before, you're much more inclined to say, well, what are we going to do when ops kicks in? Let's hope you had that idea and well before you're entering production at that point. Um, but yeah, it's crucial that you think about those as
It's
well.
crucial, and what you just said about being able to reuse the same commands and so on to take corrective actions is is uh, is a way to help them in the future, even if you
Yeah.
don't know exactly today. Okay, what are the end user actually going to face as issue, ask to have some corrective stuff. So that's kind of a good, really good tip.
Yeah.
Okay, I think we're about the end of our time, unfortunately,
Cool.
because yeah, time goes fast.
Yeah.
That was really interesting, Yves. Thanks a lot.
You're welcome.
If you have any other topic, just ping me because I love talking to you. Thank you.
Okay.
Thanks a lot.
Thank you.
Bye.
Bye bye.